The qnorm function in R is used to find a value along the x-axis that puts a certain percent of the area under the curve in one of the tails. The function has 5 arguments, just like the pnorm function. The first argument is p, and this is the area under the normal distribution in one of the tails. The second argument is the population mean, with 0 being the default value. Next is the population standard deviation, and the default is 1. The fourth argument is lower.tail equals true. If you want the area to be in the upper tail, change this to lower tail equals false. We won't be using log probabilities, so you can ignore the fifth argument. If scores on an IQ test are normally distributed with a population mean of 500 and a standard deviation of 100, what is the 60th percentile? 60% of the scores are below this point, so the lower tail area is 0.6. We can use qnorm to answer this question, and the rounded answer is a score of 525. The next question we can answer with qnorm is this. The middle 95% of test scores fall between what 2 points? For clarity, I will call the lower point score 1 and the upper point score 2. If the middle 95% of the area falls between these 2 points, this means that 2.5% of the area is below score 1 and 97.5% is below score 2. So using p equals 0.025 and p equals 0.975 with qnorm solves the question. The middle 95% of the scores fall between 304 and 696 rounded. Another way to work this is to realize that 2.5% of the area is below score 1 and 2.5% of the area is above score 2. Using the default values for the mean and standard deviation, along with lower tail equals false, we will find the z-value at the 2 points. The code on this slide is similar to a method I use to find something called confidence intervals. We'll study this concept in Lesson 3. In lines 1 and 2, I've saved the population mean in an object named mean, and the population standard deviation in an object named SD. In the third line of code, I find the z-value that puts 2.5% of the area in the upper tail, and I saved it in an object named z. In the fourth line of code, I found a value, the z-value times the population standard deviation. I will subtract this value from the population mean and add this value to the population mean. In the fifth line of code, I use mean plus c, open parenthesis, minus me, comma, me. This trick uses the c function to add and subtract the margin of error to and from the mean. The answer is saved in an object named ans. Finally, I round the answer to 4 places, and I find 304.0036 and 695.9964. A lot of problems in statistics asks you to place a certain percent of the area under a curve in the upper or lower tails. In this question, we have a standard normal distribution, and we want to know the z-point or z-value that will put 1% of the area under the curve in the upper tail. So here are 2 solutions. First, I use the default lower tail equals true and use qnorm 0.99. This puts 99% in the lower tail, so it also puts 1% in the upper tail. The second solution changes the argument to lower tail equals false to find the upper tail's z-value. Thanks for watching the video. We'll be using qnorm and similar functions for other probability distributions throughout the class, so understanding how to use this function in R will pay dividends down the road. Please let me know if you have any questions.